I don't always overpay for my capacitors, but when I do, I prefer unicorn tears. Welcome back to the workshop, everyone. It's Tim for Tim Krause Electronics. We're taking a little bit of a break from the tube preamp pedal build series because the circuit boards for the speaker emulator have not yet arrived. But fear not, there will be a build this week. In the guitar community, there's a lot of talk about mojo and magic components, and in many cases people are willing to pay huge amounts of money for a pedal or an amp that's built with these magic components. And of course there are numerous ongoing debates about whether or not certain magic components really make any difference. One example is carbon comp resistors. I'm sure a lot of you are aware of this debate. Some people will tell you that it's the only type of resistor that you should use in a guitar amplifier. Other people will tell you you don't get any sonic benefits except in certain places like the phase inverter. Another example is power supply filter capacitors. Some people will pay 5 times as much for a special power supply filter cap because it says Sprague on the side. Other people will tell you you're not going to hear any difference. Just get a good quality capacitor, that's all that matters. Now, while I would eventually like to address these specific controversies, today's build is going to focus on something a little bit broader in scope. Ladies and gentlemen, I give you the tropical fish capacitor. These little striped beauties were once manufactured by Mullard and have long been out of production. They've been out of production for decades now. They are prized for guitarists for their smooth, warm tone, and I'll admit they're a personal favorite of mine. If I could, I would probably build all of my pedals using these. They just have such a nice sound to them. But these are just one ingredient in the secret sauce for today's build. We're also going to be using some very rare and very special clipping diodes. This is the RCA 1N3253 diode. These are extremely hard to come by and very expensive. I saw someone selling one on eBay the other day for $15, just one diode. Someone else was selling one for $5. Even at that price, it seems kind of absurd to sink that much money into a single diode unless you know that you just can't get the sound you're looking for any other way. This is the other diode we're going to be using, and it is by far my favorite clipping diode. This is a 1N949 germanium diode, and it has this fat low end that you just can't get from any other clipping diode. None that I've heard, anyway. I bought a bunch of these a while back from someone who was going out of business, so it was a really good price, so I've got a small stock of these. And while they're not as rare or expensive as the 1N3253, they're expensive enough that I wouldn't want to use these unless I had a specific purpose for them. Finally, the transistor we're going to be using for this build are these BC109s. This is a silicon transistor. It's one of the nicest sounding transistors I've ever tested, and it's a favorite for silicon fuzz faces for that reason. Like the other components I showed you, because of the scarcity of these, they tend to be a little bit more expensive than current production transistors. So now the question remains, is there any real difference between these fancy, rare, and expensive components and just standard off-the-shelf components? I believe there will be. In fact, I know that there is because I've heard the difference. So perhaps a better question would be, is it an important difference? Is it just different, or is it actually better? And if so, is it enough of an improvement to warrant the huge difference in cost between those fancy components and off-the-shelf components? That's what we're going to find out in this build. For this experiment, I've got 2 of these circuit boards that came out of an old PVPA head. These are identical. This one I've already done a little bit of experimenting with. Actually, I did that years ago, but nothing I can't undo. And these are already populated with some tropical fish capacitors. That's what came from the factory. So here's the schematic of the circuit that's on these boards currently. You've got 2 input gain stages, each with its own volume control, and then a standard James tone stack with the bass and treble control. Now, since I'm a David Gilmour fan, and I've always liked the tones that he got from Big Muffs and various Pete Cornish pedals that were basically modified Big Muffs, and because these boards are so well suited, I am going to turn these into a Big Muff style distortion pedal. It's not going to be a Big Muff. It's probably not going to be as fuzzy as a Big Muff, but it's going to be that same basic circuit. It'll have a different tone control than a Big Muff has, but I've never really liked the extreme mid-scoop from that tone control, and while it's easy to tame that, I think we'll get better flexibility from a James tone stack anyway. Both circuits will be identical. One of them will use all of the fancy expensive components, the BC109, the fancy clipping diodes, the tropical fish capacitors, and the other one will use just regular off-the-shelf components, the same capacitors and transistors that you would find in any good quality distortion pedal. Here's a schematic of the finished product. This is what these will become. First of all, I'm going to have to add an additional transistor stage and input buffer on a separate circuit board because two of the transistors that are already on here are wired as buffers, one before the tone controls and another one at the output, so we wouldn't have enough gain stages for what I intend to do. The volume control for the first channel will be relocated and it's going to become our gain control. And then we're going to add in these components to the feedback loop of the two channel input transistors. One pedal will use 1N3253 and 1N949 diodes, as I mentioned earlier, and the other will use much less expensive 1N4148 and 1N34A diodes. Now notice that I've got each pair of diodes coming off their own capacitor rather than a single cap for both pairs. There is a reason for that. At the end of this experiment, I'm going to play around with the values of those capacitors to see if we can get the cheaper diodes to sound more like the more expensive diodes. The tone controls are going to be tweaked a little bit because the stock values placed the center frequency of the mid-range a little bit too low for a good guitar tone. Remember, these came out of a PA head, so what's good in a PA system is not necessarily good for guitar tone. So now we're ready to start modifying these boards. The first thing I'm going to do is go through and take out all the components that I don't need anymore. So let's get started. Now this first one I'm taking out is actually the power supply filter capacitor for this board, but because it's so old and it's actually only 10 microfarads, which is way smaller than we're going to want, I'm going to take this one out anyway and we'll put a larger one in. And these other electrolytics are emitter bypass caps, and we don't need any of them for this circuit. Okay, I'm going to pull out these pins that are left over from the old pots when I removed this board. I probably shouldn't have done it the way I did, but I just clipped off the leads on the pots instead of unsoldering them. I probably could have reused them, but oh well. Now all the stock transistors on these boards are these old flying saucer style JFETs. The last three of these are going to stay in here because for the purposes of this experiment, they're really inconsequential. It's not going to affect what we hear and don't hear as long as both circuit boards are the same. On the other circuit board, I've actually removed, because I kind of messed around with one of these several years back, I ended up removing all of these and replacing them with some other transistors. So now I'm going to use a heat sink when I take these first two out because I need to reuse them in the other circuit board. So for that, I've got one of these spring-loaded aluminum clip style heat sinks. I'm just going to slide it on there. And now we've removed the old JFET. I can tell it did not overheat because I grabbed it right after I pulled it off the circuit board and it didn't feel warm at all. So this will still be good. These two 47 picofarad ceramic disc capacitors here are coming out too. These were just in the circuit just as a kind of an inexpensive way to filter out some radio frequency interference. But because the input buffer I'm using already does that, I don't need these, so those are coming out too. So now where that power supply filter capacitor was, that 10 microfarad capacitor, I'm going to put in this 47 microfarad capacitor. Now this is not the only filtering stage, otherwise I'd use a larger one. This is there's going to be a 220 microfarad capacitor earlier on in the power supply. Now the transistors that I pulled out of here, these JFETs, have a pinout of gate source drain, which corresponds to base emitter collector on this transistor, but the pinout on this is emitter base collector. So I've had to twist a couple of these leads around each other to make this work in here. These collector resistors are 22K, which is already a good value, so we're going to leave those in there. But the emitter resistors are 3.3K. That's too high. We're going to lower those so that we can get more gain out of each stage. Now, sometimes this solder wick just doesn't want to soak up the solder, so I have this little tub of flux, and I'll just give it a quick wipe through the flux. And then it works much better. I don't want to pull too hard because I don't want to risk damaging this circuit board. Yep, getting right out. So now I can put these new emitter resistors in here. Now, I left my schematic at home. I meant to print it out and bring it here, but I just forgot. So I could probably do the rest of this from memory, but I'd rather not because I'll probably end up putting the wrong component in here in a couple spots, and I'll have to just undo it anyway. So instead, when I come back to the workshop tomorrow, I'll get back to this part. But for now, what I can do is I'm going to drill some holes right where these, I'll show you the traces on the back. The potentiometers used to be mounted right there, and there. So I've got lots of empty space on the back of this circuit board, and I'm going to use that to mount some eyelets. And those eyelets are going to hold all of the clipping diodes and everything else that goes in the feedback loop of these two transistors. So I'll drill some holes and mount these eyelets, and then tomorrow when I come back I can finish the rest of that. Okay, so now I've got all the holes drilled for the eyelets, and I'm just going to put this staking tool in the drill press and use that to stake those eyelets. Now, seating these eyelets is a little bit more difficult than it normally is. Normally you'd be seating eyelets on a blank circuit board. This already has a bunch of stuff on here, so these are, you know, every spot where I've got a component soldered in here, there's a little bump from the solder on there. I can't do this flat, otherwise when I try to seat it, it'll just push the eyelet right out because, you know, there's stuff under here keeping this from sitting flat on the metal surface here. So what I've had to do is I've clamped a file in place here, and it's got, you know, the skinny end, the handle here is what the eyelet will actually sit on when I seat it, so that there will be space on either side of this. And the last one. And there they are, 20 eyelets altogether. That's going to give us a nice solid foundation for the clipping diodes, bias resistors, and anything else that needs to go into the feedback loop of these first two transistor stages. So I've put the first couple of clipping diodes in here just so you can see what they're going to look like when everything's mounted in there. And I had originally planned on using a tropical fish capacitor for this position here. This is the 0.15 microfarad capacitor that's doing the DC blocking for the clipping diodes. But because of the lead spacing of those tropical fish caps, there's no way I would have fit it in there. So I'm just going with one of these green caps that I've got in stock. And as long as it's consistent between both circuit boards, it's not really going to matter, because all we're really listening for is the difference between the components I put in this board and the components I put in the other one. Alright, I'm back again, and today I remembered to bring the schematic with me. One of the first things we're going to have to do here is relocate this capacitor, because this is actually the input capacitor for this second stage, and because it's coming off of the output of the first stage, we already have a capacitor here, and so this is unnecessary, but we do need one right here at the input of the first stage, because at some point I took that capacitor out. So we're just going to unsolder this here and move it over. Now I have another one of these heat sinks that I have ground down on a bench grinder a little bit just to make it easier to fit into small spaces like that. And I'm going to use that on these tropical fish caps because I don't know whether or not these are heat sensitive, and I don't want to risk damaging these. So now that's moved over. The next thing we need to do is connect the output of the first stage to the input of the second stage. Now this output capacitor on the first stage is going straight to the top lug of its volume control. We're not going to be using that because our volume control is going to be it's going to be tied in elsewhere. So what we can do is take a wire from this pad for the top lug of the original volume control and bring it over to where this second channel input resistor is. I'm actually going to move this over to make it a little bit easier so I don't have to have a wire running all the way up here. I'm going to put this in where we just took the capacitor out. Hot. And here's the .001 cap that we're going to be putting in there. Right now, the mixing resistor coming off of the bass control is a 100K. We're going to change that to a 33K. And then also the two capacitors on the treble control right now are a 0.0047 and a 0.047. Those are going to get changed to a 0.001 and 0.01. Well, apparently I forgot to order the 0.01 microfarad tropical fish caps, which is kind of a bummer. So I'm going to have to use these regular film caps that I use in my other pedals. You know, again, as long as it's consistent between the two boards, we'll still be able to hear what the difference is. I would have liked to use them everywhere just to kind of maximize the amount of effect that we got from these caps, but nothing I can do about it at this point. These will work just fine. The last change I have to make on this board is the build-out resistor coming off of the last, the output buffer. And right now there's two 22K resistors in here because it was going out to the left channel and right channel input of the power amplifier. So one of those will come out, the other one will be changed to a lower value. I'll probably use 1K for that. Now hopefully the camera will focus on this. I want you to see what happens here. See how wiggly that transistor is? That's because two of these solder joints are loose. Now I've noticed a couple of cracked joints on here and on the other board, so I'm going to go over all of them and just reflow the solder, make sure we don't have any problems with that. So now that's done, I'm going to start putting some components in these eyelets here. Something interesting I noticed, just out of curiosity, I measured these real small capacitors. These are supposed to be 1 nanofarad, and all 4 of them are between 1.42 and 1.44 nanofarads, which is a pretty big deviation. That's 40%. What's even more interesting is that even with those really poor tolerances, all 4 of these are matched within I think 2% of each other. So Fortunately, that's not going to cause any issues because they're at least all going to be consistent. It will change the EQ curve a tiny bit, but it's probably not going to be an audible difference. So anyway, now I'm ready to, I've got all the components mounted in these eyelets for the feedback loop of these two transistor stages, and now we have to actually run a wire over to the base and collector of these transistors to connect all of these to the transistor. Okay, that was the hard part. Now I've got to put some hookup wire on here. We're going to have a switch that lets us switch between germanium and silicon clipping diodes. So, got to attach some wires for that. Alright, the next step is I've got to make a separate circuit board that's going to have the input buffer and the first gain stage on it. I really don't want to do that until I get the enclosures in, because I don't want to count on having a certain amount of space to work with in there and then end up being wrong about it. So once I get those in and I can, physically put this inside the enclosure to see exactly how much room I've got to work with, then I'll go ahead and make that other circuit board. So that's it for this video. In the next video, we will finish the build and then answer that burning question, is it worth the extra money to buy the good stuff? Thanks for joining us this time. Like it if you like it. Please comment and hit subscribe below, and we'll see you next time.